It's pretty easy to romanticize old American iron. My Logan 200 was built in 1943. It was made as part of the war effort. In a way, this thing helped defeat the Nazis. See how easy it was for me to romanticize that? A lot of times the reality is more like this. My Index 40H was built in 1947. It's older than my parents. It's not a war hero. And it has a lot of wear kind of everywhere. It seems like there's constantly something to repair on this, and in this project I'm after the countershaft pulleys. I've had it with these things. No matter how hard I tighten down these set screws, they work themselves loose, they fall off, it'll spit this key out sometimes. The grooves are worn into U-shapes rather than V's. This one's JB welded back together. This one's been sleeved once already and it's cracked out again. This shaft is all buggered up. This is actually the good side of the shaft too. Surprisingly, these bearings are actually good. Probably just reuse those, but I'm just going to rebuild all of this. I'm going to make new pulleys, make a new shaft, just rebuild all of it and get it working the way it's supposed to. When I got the mill, the pulley on the motor was broken, and I made a new one out of a piece of solid 6061. This time around, I'm going to empty out my scrap bucket and cast some aluminum blanks. I made some pretty basic patterns for these, and these are pretty well oversized, so I'll still have a good bit of machining to do, but it'll save me cutting away a lot of stock. I left the largest diameter pretty thick so that I can do an open mold casting for these. This will basically just serve as the riser, so as this cools and shrinks down, I'll have plenty that I'll have to cut some of it away, but it should give me a pretty good piece to start with. The sand here is just a mix of play sand pirated from my son's sandbox and some ground up kitty litter, a little bit of water, usual backyard casting mixture. It's about 15% kitty litter, 85% sand. So I didn't get it rammed in very well right in these steps, but this is a learning experience for me, so I'm going to try it again. So that's still a pretty terrible mold, but for what I need, I think it's going to work. So I'm going to go ahead and cast this one and see what I can learn from this before I do the other one. If you're watching this and thinking, this guy doesn't know what he's doing, you're partly right. But what I'm doing is I'm learning. And I'm the type of person that learns by doing, and that means learning by failing. And this was a pretty spectacular failure. But I've cut way back on the amount of moisture in my sand, and I'm going to give this another go. That went a lot better, but suddenly I have an urge to whip it good. I'm going to call these crude but effective. Basically, I just needed a chunk of aluminum that's the right size, and I think I've got it. I've still got a lot to learn about sand casting. With these flaws in it, there's not really a great way to hold this in the lathe. I'm not going to be able to grab it there very well. But the large diameter is too big for the chuck. So what I'm going to do is just go ahead and drill, ream, and broach a keyway through the middle, and then put these on a mandrel. I made this mandrel for making the pulley that's on the motor on the mill. It has the key in it that's the right size, so I'm just going to reuse it for this. I've got it trued up in the four-jaw chuck, and a little super glue. Since I've got a lot of material to remove, I'm using it as an opportunity to try out a bunch of different tools, different geometries. I've settled on a high-speed steel tool with a moderate nose radius and a lot of rake to it. I'm running it a little bit slow because this stuff might be a little bit gummy, but overall it's machining pretty well. It's not making the usual aluminum razor ribbons of death, which is nice. Surface finish isn't great right now, and it does have some porosity, but it's okay overall, it'll work. Having established this face, I'm working out to establish the other faces and the other diameters. These are all on diameter now, and I'm just working on getting the faces at the right place. This is roughed out at this point, and I actually have something here that I can hold in the forejaw, so I'm going to flip it around and do the back side. I kind of thought that something had shifted with my setup before, so I indicated this off the bore, and it does have a good bit of run out on the surfaces that are already machined. So when I roughed it out, I left a bit of stock, so when I go back, I can set it up again on a mandrel, make sure everything is really square, and finish it that way. But right now I'm just focused on doing the back side of it. It occurred to me that rather than turning on this mandrel in a chuck, what I should do to ensure that this stays concentric is to turn it on a mandrel between centers. And since I'm going to remake the shaft anyway, before I finish the pulley, I'm going to go ahead and make the shaft and use that as my mandrel. And for that, I found this CV axle from a Subaru. This will either be way too hard to machine or make a really nice shaft. Either way, I'm going to find out. I just wanted to make sure before I hit this with carbide that I can actually cut it with high-speed steel, so when I get over on the mill I can actually cut the keyways in it. So I know that this lathe is old and worn and cuts a taper. So what I've been doing is I have an indicator on the tailstock, and I've been taking light passes like 5 thou at a time and tweaking the tailstock back and forth until I'm getting this straight. So I'm basically using this to align things to where the carriage is actually moving rather than the actual center line of the spindle. And I've got it within a few tenths now, so now I can actually start cutting it down to size. I've got this flipped around now so I can do the other end. I did go back and redo this because I realized I wanted it a little bit longer since the new pulleys are going to be a little thicker than the old ones. And I also want to make it the correct diameter. Well, the bad news is that was my last 3/16 end mill, but the good news is I have keyway on one end of this, which should at least let me turn these pulleys while I'm waiting to get some more. Everything here is turned to final size, final width, final diameter. So what I'm going to do now is start plunging a slot down the middle of each of the steps. There's a little bit in the tolerances of each step, and I'm going to leave that extra tolerance in this area, so the slots will actually be offset a little bit, but that just gives a little bit more thickness on this part of the pulley. I'm just using the compound to set these grooves. These are just rough, so it doesn't have to be exact. The included angle on these smaller sheaths is 34 degrees, so I have the compound set at 17. I'm cutting this down until this is 87 thousandths, so I have a little bit more to go, and it should hit the bottom there at some point as well. Because I left some extra stock here, I'm basing the edge of this groove off of the distance from here to the edge of this groove. And it's not super precise, but it doesn't need to be. This bigger sheath, because it's over 5.4 inches, has an included angle of 38 degrees, so I'm going to knock the compound over 2 degrees here. I shifted this thing out on the mandrel so that the mandrel is just shy of the end here. The second pulley is basically the same process as the first, just a little bit bigger. They do make special extra long taps just for this purpose, called pulley taps, but of course I don't have one of those. 13/64 wrench. Isn't it amazing the times we live in when I can say I don't have something and then realize I need it, and a few seconds later have one? In the process of figuring out what recess I need in the back of this pulley, I realized that this bearing is in pretty bad shape actually. It's kind of beat up. While I'm here, I'm going to go ahead and replace these bearings too. It turns out this is a metric bearing, which means that this straight shaft isn't going to work. On top of that, there's even a step in between the bearings to keep them spaced apart. So I'm going to call this a pretty nice mandrel that I'm going to keep in a drawer and use in the future. And it was also a good lesson in hard turning and hard machining, mainly that I don't want to do it if I can avoid it. This time I'm going to make the shaft that I'm actually going to use, and I'm just going to use it out of this 10 something something. This should be perfectly suitable for the shaft. I'm not going to show the whole thing because you've already seen me make a shaft once, and it's basically the same just with some turning shoulders on it. Just a little bit of heat from the heat gun here. I've got a little get her out job to do before I can get this thing put back together. This bolt is broken off, but luckily this hole goes the whole way through. This is just about the perfect scenario for this because I can center it up on the back side, which should spin the broken bolt out the bottom. Easy enough. So after getting that all back together, this pulley was wobbling really badly. The original pulleys had the set screws at 180, so that's what I copied on this one. So there's not really anything holding it side to side. There was a lot of play side to side on this. But after fiddling with it for a while, what I figured out is if I tighten the one opposite the key first, it's bearing on the 2 points on the outside of the key, and then I can tighten the key down, and now it's nice and solid. It took a whole bunch of fiddling to get the belts aligned more or less right, and I had to go back and open up the recess on the back of this one a little bit so it would sit down enough. But I think I finally got it. I'm going to do something that I haven't done a whole lot in the past, which is to put this on the highest speed. Until next time, I just want to say I'm still trying to figure out how to sign off these videos.